pressure looks good.
Throttling up. Roger roll with Atlantis.
Water towers can fly! Yes!
Tango Delta nominal.
Fighting outside speed off. Bring in speed off.
Yikes. You bet. Concur. We don't need any more of these.
Hello everybody and welcome to our live coverage of the launch of GOES-T, America's newest weather satellite. You are looking live at Space Launch Complex 41 at the Cape Canaveral Space Force Station in Florida, where a United Launch Alliance Atlas V rocket is preparing to launch the GOES-T mission. My name is Thomas Burkhardt. I'm the news director here at NASASpaceflight and offering some commentary for today's launch coverage. And we are joined out in the field by Mr. Chris Gebhardt, Assistant Managing Editor for NASASpaceflight. Chris, how is it out there at Cape Canaveral today?
Well, Thomas, in a word, windy. Far more windy than I think we expected, but otherwise gorgeous weather. So we will see what happens here as we march toward liftoff.
Sounds good, Chris. Also joining us on commentary for today's launch is Hagen Warren, writer for NASA Spaceflight. Hagen, how you doing today?
I'm doing great, Thomas. Super excited to see this awesome weather satellite get off the ground.
Fantastic. And also out there in the field is Julia Bergeron, reporter and photographer for NASA Spaceflight. Julia, how are you doing today?
I am doing well. The gray skies have cleared into blue, and it seems like there is a lot of interest in today's launch. So I'm looking forward to it with y'all.
Absolutely. And we have also got Michael Baylor handling the buttons and levers in the background to produce today's stream. So thank you, Michael, to your work as always. The NASA Spaceflight team bringing you live coverage of today's launch. Again, this is an Atlas V rocket in the 541 configuration, which means we're going to get some good solid rocket booster rumble from today's launch. And the launch window opens at 4:30. Wait, do I have some math in my head? 36 or 38? Oh no, I forgot the T0 in my head.
4:38.
Thank you, Chris. 4:38 p.m. Eastern Time. And that's a 2-hour launch window. So far, everything on track for the opening of the window. We've got that clock on the upper left showing us just over 34 minutes until launch. But should any issues arise, they do have 2 hours of window to push into. But everything on track so far, and as Chris mentioned, the weather looks great. Currently, a 70% chance of favorable weather is forecasted, and that has been cooperating so far, and no technical issues being worked so far. Throughout the course of the broadcast, before we get into today's mission and what the GOES-T mission is all about, do want to give a big thank you to everyone who sent support and tuned in today. If you have questions that you would like to ask the team throughout the course of today's coverage, please tag us with @NASASpaceflight in chat, and we will try to answer as many of those as we can throughout the course of the stream. And first things first, we've already got some super chat messages coming in. Oh, and these are good ones. The very first message, what is that place under those 4 lightning towers? Y'all are getting creative with the 4 tower questions. I appreciate that. That's actually the launch pad, I think is what you're referring to there. Thank you for the support. Modi Space Industry says, Goes Thomas Fan Club. I see what you did there. Appreciate the support as always. And Bunker the Husky has become a launch director member, so thank you so much, Bunker, for your support as well. Ladies and gentlemen, this is the newest weather satellite. The GOES program is the weather satellite program operated jointly by NASA and NOAA, and GOES-T is the newest spacecraft to join that constellation. And there's a lot of very important capabilities and even some changes from the previous GOES spacecraft that are launching on this particular mission. So as those questions start to come in, Hagen, would you like to give us just an overview about some of the benefits and things that come from the GOES satellite program?
Totally. So GOES-T is the newest, the latest, the best weather satellite that NASA and NOAA have jointly developed and built together as part of the Geostationary Operational Environment Satellite Program, or the GOES program. GOES-T, as you would expect, improves off of its predecessor, GOES-S or GOES-17, which launched in March 2018 atop an Atlas V. GOES-T will provide numerous capabilities that sort of produce off of the capabilities and improvements that GOES-S and GOES-17 made whenever it launched. So GOES-T will be able to provide better detection of heavy rainfall and flash flood risks, will provide better monitoring of smoke and dust, earlier warning systems of lightning, tornadoes, will provide improved hurricane track and intensity forecasts. So really will help improve the United States weather prediction and how we deal with certain weather events in the United States.
Definitely. Also, you may have noticed in prior coverage of the GOES program that the previous satellite, which was called GOES-S, was redesignated GOES-17 after launch. Basically, the satellite has one designation during launch, and then once the launch is successful and the spacecraft has entered its operational orbit, it gets redesignated with a number instead of a letter, which helps clarify some things in the event of a launch failure, which was obviously more common earlier in the program than it is now. But nonetheless still a standard part of procedure and not uncommon for many different types of payloads, not just the GOES program. But the previous satellite, GOES-S, actually had some issues with one of its instruments on board. There was a heating line that was acting up on one of its instruments and causing the spacecraft some issues. And that issue, part of the reason this particular mission has been delayed a little bit was so that the Lockheed Martin teams, Lockheed Martin does produce the spacecraft, were able to apply some corrective actions and help prevent that issue going forward on this spacecraft, and also the GOES-U spacecraft, which will be the final member of this series of GOES satellites, launching on a Falcon Heavy in a few years. This will be the last GOES spacecraft to launch on an Atlas V rocket. And again, I'm going to keep the questions coming here because we got a whole bunch of them coming through. Musical Wolves asks if there's any cruise ships nearby. So far, no reports of any range violations, so looks like the cruise ships are cooperating. Appreciate the support there.
Thomas?
Uh-oh.
Well, there are two
Yes.
in port. There are two in port right now, just letting you know.
Okay, but are they moving? Are they moving?
No. They are docked. Just so y'all know,
Okay.
they are docked. They are not at all near me by the boat ramp, so we're good.
That is
And I think
good
another
to
thing
know.
to sort of point out about it's not going south like the ones
That's
a
true.
lot of the ones this year have so far. So that will be in the sea exclusion zone's favor in that regard today, more than normal closures that we're used to here on the East Coast.
And you know, that ties right into some of these questions that we're starting to get into chat, so let's dive into them. The first one, which direction is this Atlas V rocket going after it lifts off? And as Chris just mentioned, this is not flying south, it is also not flying north, in fact it is flying due east, and that is because this satellite is going to a geostationary orbit. Now, there's a lot of different ways to get to geostationary orbit. We've got a cool graphic there provided by United Launch Alliance to kind of show the trajectory relative to the Earth's surface, which means it actually, you can see it's got some weird kind of curves and lines to it because as you get farther away from the Earth, you almost start to drift west at the very end of that trajectory. Some cool orbital mechanics at play there. But basically, when you're going to geostationary orbit, you want to get the minimum inclination possible because eventually the spacecraft will have a 0-degree inclination. However, since they are launching from Cape Canaveral, the minimum inclination you can reach in your first kind of orbit is the latitude of the launch site, which is about 28 degrees or so at Cape Canaveral. So they will be flying due east to minimize the plane change maneuver that the spacecraft has to do. And what that means is once the spacecraft and its Centaur upper stage, the upper stage of Atlas V, passes over the equator, it will do a maneuver to reduce its inclination down to about 9 degrees or so. That's the target transfer orbit that this particular mission is flying to. So this satellite isn't going to be inserted directly into its operational geosynchronous orbit. The rocket doesn't quite have the performance to do that, but it does have enough performance to give it a little bit of help along the way. Do a little bit of that plane change maneuver for it, get it down from the 20-something degrees down to 9, and also it will raise its perigee a little bit. The lowest point in that orbit from a kind of standard geostationary transfer orbit that's really elliptical to start to raise that lowest part of the orbit, just not all the way. To do that, Centaur is going to perform 3 burns. The first one will just reach an initial low Earth orbit parking orbit. The second burn will raise the highest point of the orbit, the apogee, out to geostationary altitude, and then that will also be conducted over the equator. And then the third burn will conduct a little bit of a plane change and also raise the perigee a little bit. And that is the transfer orbit that GOES-T will be deployed into, assuming the launch operates nominally. So a bit of a helpful transfer orbit from Atlas V. This configuration does have 4 solid rocket boosters on it, so not the most powerful version. It's not all 5, but it's pretty close. And using some of that extra performance to help GOES-T get where it's going a little bit quicker. Some other questions coming into chat here. Amiga Clone asks how many Atlas V launches are left. This particular launch is, of course, of the Atlas V rocket, which is being retired by ULA in favor of the new Vulcan rocket, in part because of the first stage engine, which is a Russian-built engine. ULA wanted to transition to American-made engines on the Vulcan rocket. But after Ghost T, there are 24 remaining Atlas V launches, so still a fair amount to go. A lot of national security missions and other government missions, also some missions for the Amazon Kuiper internet satellite constellation, among other missions. So still a fair amount left, but Atlas days, there are a set number of Atlas V missions left.
And worth mentioning too on that front that you just talked about in terms of the engine. So the actual decision to switch away from the RD-180, which sort of kickstarted the fact that we needed a new rocket, or ULA needed a new rocket after Atlas, stemmed from the Russian invasion of Crimea back in 2013.
Yep.
And that's what sort of kickstarted all of this. So wanted to take a moment to stop and say it's not actually because of the current Ukrainian invasion of Russia, but it is the previous one that led to the Atlas's ultimate retirement with Vulcan.
Yes, absolutely, and definitely worth noting here. I do believe it's also worth mentioning on that same topic that all of the RD-180 engines that Atlas V will use throughout its retirement have already been manufactured, I believe.
And are here, actually.
And are
ULA
already here
has
in the
possession.
States, right?
Yes.
So that is obviously a question that I would anticipate getting as we continue that kind of conversation. But that is not a concern for the Atlas V, which differentiates from the Antares rocket, which does still actually require a few more first stages that are Ukrainian and first stage engines that are Russian going forward. Although they have some for the next couple launches. So a storyline to keep an eye on, but not super relevant to this particular launch. So we'll end that line there, I think.
I would actually like to add one more thing about the RD-180. ULA did confirm that they do not need Russian consultation for the rest of the Atlas flights, that their flight history with the Atlas of 90 flights of the RD-180 is enough to give them the confidence to fly out the manifest without Russian input if needed.
Yes, absolutely. All right, and I'll keep some questions coming here. Eric asks, what's the max acceptable wind speed for launch? I picked this question because it's worth talking about, even though I don't have an actual answer for you. It really does depend on the mission. Different rocket configurations have different wind requirements. A lot have to do with the thrust vector control or the engine steering capability that a rocket has. Different rockets can steer into the wind a little more effectively than others. Also can depend on the actual launch trajectory, what orbit it's going into, and what trajectory the rocket has to follow to get there. Can result in the rocket staying lower in the atmosphere slightly longer or higher slightly faster. And those factors can all depend or all affect what the actual wind requirements are for a particular launch. So there's a lot of factors that go into it. It's not a standard criteria for, say, the Atlas V, for example. So I do not believe we know an actual hard number that is the limit for today. What we can also report simply is that no weather issues have been reported so far, so it doesn't seem like wind is a major concern for the launch criteria, at least today. But a very good question there, Eric. Let's see. I'll keep some questions coming here. Rough Rider Show says, given this Atlas is not powerful enough to insert it directly into geostationary orbit, could Falcon Heavy put it right into geo? I'm going to throw that out to the rest of the team here, because it also ties into this other question from Simon asking, do I presume rightly that this is the last goes on Atlas, and that goes U will probably go on Vulcan? You are correct that this is the last goes on Atlas, but goes U has actually already been assigned to the Falcon Heavy rocket. So that is the last of this current line of GOES satellites launching on Falcon Heavy. Will Falcon Heavy be able to put it direct into geo? I actually don't know. Do you guys?
In this case, it's not necessarily always a factor of going directly to geo. That has a lot of benefit if you want your satellite like DoD, Department of Defense payloads that you want to get operational immediately. The GOES series actually have about 11 months of checkouts that they have to go through in orbit before they are deemed operational. There's no need to put it directly into geo. There's really no need. Yes, you could end up saving a little bit of propellant, but we really don't let our weather satellites get to the like, oh yeah, they're at the end of their life, let's start thinking about another one. Our weather satellites are ones that we routinely replace before they reach the end of their design life to begin with. And then we sort of use them as spares, or we transfer them to other U.S. departments that might need.
That is a very
So in
good
this
point,
case,
yeah.
there's no real reason to send it right there. Yeah.
It's also even worth mentioning that this will actually be replacing GOES-S in its orbital designation, the GOES-17 satellite. However, GOES-17 won't, just be decommissioned and deorbited or something like that. It's simply going to move to an on-orbit spare position so that it can still act as a backup for the rest of the constellation. So kind of part of that routine replacement process that we go through with American weather satellites. Musical Wolves ask, when Pad Tower Watcher t-shirt? Another merch idea for the store. Thank you for the support there. And let's see. Catlin with a good question here. Thank you for the coverage, guys. Do I understand right that this particular launch will take place without the Russian team that checks the RD-180? Chris, do you want to go into a little bit more detail about how the Russian element of the RD-180 engine plays into the launch teams for Atlas V?
Yeah. So the comment that I saw from Tori Bruno, CEO of ULA, said that they do not require the Russian team that is always sort of on standby in case the engine does something unexpected. He did not indicate whether or not they would be doing that consultation for today's mission if needed, or if part of the sanctions already mean that that is not a possibility. All we really got was the confirmation that the Russian teams aren't needed from ULA's perspective to fly out the manifest.
Yep. Gotcha.
Unfortunately, there's just a lot right now that that nobody is really sure where the answer lies because of how things are developing, sometimes hourly.
Yes, correct. All right, keeping some more questions coming. Actually, Hagen, I've got a question for you because we've talked a little bit about the rocket. Geez, I'm talking too fast. Let me slow down for a second. We've talked a little bit about the rocket, but we want to talk more about the spacecraft as well. We already talked about its weather kind of capabilities and what GOES is used for that kind of thing. But GOES is a bit of a unique platform in that it doesn't only study weather on Earth, but we also take advantage of these satellites to study things like solar weather and space weather. Do you want to talk a little bit about that?
Yeah, so in the latest series of GOES satellites that GOES-T is a part of, the GOES-R series, they have a magnetometer. I'm sorry, I totally messed that up. Magnetometer on them that is able to study, the effects of Earth's magnetic field from solar radiation, solar wind, coronal mass ejections, should those come around. And so they definitely do have they play a big part in determining space weather, and monitoring the different levels of Earth's atmosphere, and also, like I said, its magnetosphere, to determine the effects that certain solar weather has on Earth's orbit, satellites, on the ground here with radio communications and such. So yeah, these GOES satellites really play a big part in just monitoring how Earth is doing, really, in terms of weather, solar weather. So yeah.
So I have a quick question for you, Hagen.
Mhm.
So now recently a batch of Starlink satellites was lost due to space weather. Would an asset like GOES-T help predict whether or not it would be wise to launch a batch of satellites?
Very good question. So Chris and I recently just spoke to a space weather scientist at NASA about the coronal mass ejection and geomagnetic storm that took out the Starlinks. And we talked about how we could possibly predict solar weather and such, and they're definitely working on it. And in terms of GOES and such, there is a possibility that they could determine some solar effects happening in the magnetosphere, and that could help certain launch teams on the ground determine if they want to launch a certain batch of Starlinks or another satellite into space at a certain time. But right now, really, predicting coronal mass ejections and geomagnetic storms, that's still a topic of study that we're still trying to figure out. So right now, it'll
And I
likely be
think
a
one of
bit
the
hard.
interesting things from yeah, and I think one of the interesting things from that interview, Hagen, I don't know what your the part that stuck in your mind most was, but to me it was pretty much like we're just we just don't have the information we need yet to be able to predict these things. This is what the Parker Solar Probe and ESA Solar Orbiter are sort of doing and looking at. But to your question specific, Julia, it's almost as if these satellites can provide a snapshot of what's actually happening now, but not a prediction of what it will be in the future. Because one of the interesting things they've said is we see these coronal mass ejections racing across the solar system. They hit our sun sentinels at Lagrange point 1 between the Earth and the sun, about 1.5 million kilometers ahead of us in terms of closer to the sun. And they'll be able to generate rather quickly, oh, this looks like it's going to be a big event, and then it turns into nothing. And then something they think isn't going to be something turns into something big or bigger than anticipated, like the event that took out the Starlink. So we just don't know. It's we talk about weather prediction here on Earth, and we can see the hurricane coming. We can give decent predictions for tornadoes and stuff like that, but we can't do it for space weather yet. We really can't.
Yep.
Again, folks, if you've got questions, please feel free to throw them in the chat. We're getting a whole lot of really good ones here, so I'm going to keep them coming. One question here from Robert asks, since this is a NASA rocket, why is it on a ULA tower? Talking about the ULA launch tower that we see just next to the rocket and the rocket itself. This is actually an interesting sort of thing to talk about, because I guess we don't talk about it that often. So NASA is jointly operating the satellite, the mission, along with GOES. Basically how they divide these up for the GOES, with NOAA, they're operating GOES together. My apologies. The way they kind of split this up is NASA handles a lot of the spacecraft kind of build itself and the instruments. In this case, they work with Lockheed Martin as a contractor to actually build the satellite. And NASA also handles procuring the launch services. So the NASA Launch Services Program is what bought this Atlas V rocket to handle this particular launch. And then once the satellite gets to orbit, NOAA, the National Oceanographic and Atmospheric Administration, actually operates the satellite itself, with NASA continued cooperation as well, but NOAA is actually the primary operator of the satellite once it reaches orbit. However, neither of those groups operates the rocket itself. NASA purchased the rocket and the launch service from ULA, but United Launch Alliance is still the launch provider, and so ULA is operating the Atlas V rocket on behalf of NASA and NOAA. The only kind of rocket that NASA themselves actually operates would be, for example, the Space Launch System, which is owned and operated by NASA rather than purchasing launch services from a commercial company like ULA or SpaceX or something like that. In the past, if you go back into the recent NASA history, the Space Shuttle was another example of that. And if you go back farther and farther, it kind of evolved from NASA owning and operating rockets to private contractors owning and operating the rockets and NASA purchasing the launch services, kind of a different contracting structure. So I'm not sure it would be super accurate to say that this is a NASA rocket. It is a NASA mission launching on a ULA rocket, and that's kind of explaining what you're seeing there. Very good question. Also, we got a question kind of following up on something we talked about earlier, how this satellite will be replacing GOES 17 on orbit. Marcus does mention that GOES 17 has All right, folks. Sorry about that. Looks like we had a brief technical hiccup there. Let me know if you can hear me again. You should have us back. I don't know if the end of that question got cut off. However, 5x5 in chat. Thank you. Sorry about that, everybody. You quickly just recap the end of that question there about the replacement. This satellite is replacing GOES 17. However, GOES 17 will continue to operate as a spare for all of the other GOES satellites, even though it is being replaced by the GOES T mission. So thank you for that question in chat there. Moving on to the next question here, Matt asks, how do they deorbit satellites from orbits like GEO, or once they are at the end of life, do they just stay as they are? Chris, you want to talk a little bit about that and the whole graveyard orbit thing?
Yeah. So it's actually not that efficient to deorbit something from geostationary orbit. So, and because geostationary orbits are already very, very, very stable, like stable for thousands upon thousands of years from atmospheric drag, it's actually better to just move them up into what is known as the geo graveyard. And this is a orbit that's about 300 kilometers higher than geostationary. And basically, you just move the satellites or spent upper stages of rockets, if you can, after direct geo insertions. You move them up into that graveyard orbit, and then they really never bother anything again. You passivate the propellant tanks to avoid accidental explosions due to overpressure events or things like that. And then it's just a really stable to basically put your trash in orbit.
Gotcha. Thank you for that. We are getting to the business end of this countdown. We're getting a lot of super cool questions, so I'm going to keep them going as quickly as I can. I do want to acknowledge that we are at L minus 9 minutes, and that ties into this question. What's the difference between T minus and L minus? So for a United Launch Alliance countdown, different companies handle their countdown slightly differently. ULA is actually currently at T minus 4 minutes and holding, and that is part of a planned hold that just allows the team to work through any issues that have come up earlier in the countdown. Can also just be stable and hold at this point if weather isn't cooperating or some sort of range issue is being worked. The rocket can just sit at T minus 4 minutes and hold indefinitely until they are ready to proceed. Right now, the L minus clock is continuing towards the opening of the window, which is 4:38 p.m. Eastern time. That is the opening of the window, and all systems are on track. And the T minus clock will sync up with the L minus clock, assuming no issues come up in the next 4.5 minutes or so, at that 4-minute mark. And then both clocks will match each other the rest of the way to the countdown. So it's the difference between the clock, the time that is on the clocks that's synchronizing all the countdown events, which is that T minus clock, and then the L minus clock, which is actually the amount of time until liftoff, and that's why we show the L minus clock, because that's the time that you are most interested in, because none of you are payload computers. But thank you for that question. As we get closer to that 4-minute mark, and our producer Michael Baylor will jump in and let us know when we have to shut up and listen, because we will listen into that go no-go poll from the United Launch Alliance launch teams as they poll their final readiness to proceed from the T minus 4-minute mark. And we're coming up on that in a couple minutes here, so we'll keep on an eye out. And once we get close to that, we'll stop talking and listen into that. But otherwise, we've got a couple more questions here I'd like to get to. Matthias asks, which variant of the Atlas V is this mission? This is the Atlas V 541, and those 3 digits stand for 3 different characteristics of this rocket. The 5 is the 5-meter payload fairing. That's the larger of the 2 versions of the payload fairing on Atlas V, and is being used for a couple reasons. The 5-meter fairing is obviously used for larger spacecraft, ones that physically need a bigger envelope to sit in, but also for the Atlas V missions that need more than 3 solid rocket boosters, either 4 or 5, such as this mission profile. The bigger fairing is also used to help carry some of the aerodynamic loads that come with having a lot more solid rocket boosters at the beginning of flight. And this particular mission, the 4 in the 541, indicates 4 solid rocket boosters. So the big payload fairing also helping with the loads from those 4 solids. And then that final digit is a 1, which means there's 1 RL-10 engine on the upper stage, the Centaur upper stage. And here comes the go no-go poll.
Pneumatics. Go. LO2.
Go.
LH2.
Go.
ASGAS.
Go.
Electrical systems. Airborne.
Go.
Ground. Go. Facility.
Go.
RFFTS.
Go.
Flight control.
Go.
GCQ.
Go.
Operation support.
Go.
COM.
Go.
Umbilicals.
Go.
ECS.
Go.
Redline monitor.
Go.
Quality.
Go.
Ops Safety Manager.
Go.
ULA Safety Officer.
Go.
Vehicle System Engineer.
Go.
Anomaly Chief.
Go.
Range Coordinator.
Clear to proceed.
Launch Director.
You have permission to launch.
Proceeding with account. AL.
All right, and as you just heard, all of these stations have pulled go for launch. The range, the rocket, and the weather, and the payload, all systems are go for launch. There will be one final status check about 25 seconds before launch. You'll hear a go Atlas, a go Centaur, and a go Goes T, hopefully. But that was the final full poll of the launch teams, and all systems are go for launch. They've got about a minute and a half left in this pre-built-in hold before the clocks proceed from T-minus 4 minutes and counting. But 4:38 p.m. Eastern is still the opening of the window, and that is still the targeted liftoff time. Everything proceeding well so far. Julia, what is it like out there in the field? You mentioned that there was a lot of crowds and a lot of interest on this mission out in the public today.
Oh, you are correct. I am actually at the boat ramp, and the parking at this boat ramp is pretty full. And we are all lined up on the shore here, looking just to the side of us here at a full campground at Jetty as well. So I think everybody's excited to hear the rumble of the solids today.
Absolutely. Also, just a very cool example of how spaceflight benefits Earth, right? These weather satellites are one of the more obvious examples of how a space launch directly benefits everyone here on Earth. Because weather forecasting, we all use that almost every day, right? So I wonder if that also drags some attention to the launch and people like to come out and support these kind of things. Really quick, I'm going to speed run these last couple questions and some super chats that have come through as well. Again, thank you to everyone for their support. Arthur, thank you for your support. Musical Wolves asks, aren't the GOES satellites used for monitoring volcanoes too? Hagen, is that true?
Yes. Specifically these GOES satellites, they're able to monitor the volcanic ash and plume that comes from volcanoes. And that's actually one of the improvements that GOES-T is going to make whenever it is up in GEO. GOES-T is going to provide better fire detection and intensity estimation. And if you remember back to the Tonga volcano explosion a few months ago, the GOES satellites in orbit that are currently operating provided a lot of really good imagery of that event. So yeah.
Awesome, thanks. Again, speed running these last two questions before we get into the final minutes of the countdown. Again, less than 4 minutes and counting from now. John asked, why is it GOES-T and not GOES 18 or 19? Well, trick question. It is also GOES 18 once it successfully reaches orbit. GOES-T is the launch designation, and then once the satellite is successfully in orbit and ready to begin operations, it gets renamed to GOES 18. At least that is the planned designation for this mission. So that's why the GOES satellites change name after launch. And then Nifty asked a quote-unquote easy question, we'll see. What do you mean when you say inclination? That is a good question there, Nifty. Inclination is basically the tilt of the orbit relative to the equator. And for a satellite to sit above the same point on Earth as it orbits, its inclination needs to be 0, meaning it has to be orbiting directly over the equator at all times. So when they do that plane change maneuver or that inclination change maneuver, that's what they're doing. They're aligning the orbit with the equator so that the satellite doesn't move relative to the surface. That's what a geostationary orbit is, and those are the kinds of orbits that GOES satellites use. And finally, 2 quick super chats here. Orcam, thank you for your support, and Donald, thank you for your support as well. Thank you to everyone for tuning in. If you are just joining us, we are just over 2 minutes for the launch of the GOES-T satellite for NASA and NOAA. It's launching on a United Launch Alliance Atlas V rocket from Cape Canaveral, Florida. Again, launch in just 2 minutes from now. A big thank you to Chris Gebhardt out there in the field. He is out there going to be tracking the rocket with NSF's camera and tracking it as it goes downrange due east from Cape Canaveral. The rest of the NSF team here on commentary will be providing updates as the rocket ascends, and we will be tracking this mission as GOES-T makes its way to orbit to begin its trip to improving weather forecasting and science observations for NASA and NOAA. Everything on track so far. No weather items being worked, no range issues being worked, and no other technical issues. Everything on track right now. Just under 90 seconds to go. Hagen, as our resident science writer, how are you feeling about launch as we come up on launch here?
I am super, super excited. As somebody that not only loves, astrophysics and spaceflight and stuff, I love meteorology and weather. And so, we've been looking forward to Ghost T for a while. And so I'm super, super, super excited to see this awesome weather satellite get up and begin its mission.
Fantastic. And then, of course, Chris and Julia out there in the field. Also, Stephen Marr is out there taking some footage for NASA Spaceflight as well. So all three of you, I wish you the pleasant launch viewing experience in just under a minute, 45 seconds and counting. Let's take a look. $30 seconds. $20 seconds. T minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. We have main engine ignition, booster ignition, and liftoff of the United Launch Alliance Atlas V rocket from Cape Canaveral with the new GOES-T weather satellite. Let's listen in for the rumble. Just over a minute into flight, everything nominal so far. 4 solid rocket boosters and the RD-180 main engine lifting Atlas V off of the pad and on its way towards a geostationary transfer orbit due east from Cape Canaveral. The next milestone, the rocket has already gone through maximum aerodynamic pressure or max Q, so the next milestone will be solid rocket booster burnout and jettison. You're seeing a combination of views from NASA's clean feeds as well as Chris Gebhardt out there in the field for NASA Spaceflight. Looking great so far. Even getting some onboard views from the rocket, looks good. Coming up on solid rocket booster jettison, and there is the first two and the second two. All 4 solid rocket boosters have successfully jettisoned. You can see them falling away there, that RD-180 liquid engine on the first stage now doing all of the work. Next up will be payload fairing jettison. On this particular Atlas V configuration, the payload fairing has to separate before stage set because the Centaur upper stage and the satellite are both encapsulated by that fairing. Everything nominal so far, a clean ascent. Over 2.5 minutes into flight. You can see that rocket exhaust expanding as the rocket gets higher and higher and has less and less atmospheric resistance. You can also see some ice shedding from the super cold tanks of the first stage of Atlas V. The next milestone is that payload fairing jettison. You'll also see a load deck jettison right after the main payload fairing. That's used to help transfer some of the loads between the Centaur upper stage and the rest of the rocket during the early phases of ascent. You'll see both of those separation events here shortly. Over 3.5 minutes into flight now, all looking good. And there you see payload fairing separation, the fairing falling away. And there is that load deck, that CFLR deck jettison. So now remaining is that Atlas V first stage finishing its burn. We're coming up on what ULA calls BUCO or booster engine cutoff. Now seeing a live telemetry animation of the rocket. We will also see right after BICO stage separation and the first ignition of the Centaur upper stage. That's coming up next. 4.5 minutes into flight. There is booster engine cutoff. The RD-180 engine has shut down. And there is stage separation. The first stage is separation motors firing. And here is the ignition of the RL-10 engine on Centaur. And there is ignition and full thrust. The liquid hydrogen powered RL-10 engine on the Centaur stage now underway. This is the first of 3 burns for the stage to get GOES-T to its designated transfer orbit. And we're now seeing a combination of those onboard views from the rocket itself, also some animated views using the live telemetry coming from the rocket. You see we're about 5.5 minutes into flight. The rocket is actually in space, 185 kilometers in altitude and climbing, although not yet into low Earth orbit. This burn will place GOES-T and the Centaur stage into a low Earth orbit parking orbit, and then there will be 2 successive burns after that to send GOES-T towards its transfer orbit.
And what a liftoff so far, huh, Thomas?
Oh, absolutely, Chris. That was a great liftoff. We could see a windy liftoff too. ULA's Atlas V doing its good work, fighting the wind there, and we saw that track. Thank you so much for that, Chris. And love the rumble as well from those 4 solids in the RD-180. Always a good time when there's solids on an Atlas.
I'm glad you could actually hear the rumble of the solids over the sound of the wind.
Yeah, we definitely heard both, but hey, it's all part of the experience.
Yeah, I'm sure you could see how much the camera was shaking on my end as I was trying to track it as it went out. Like,
Oh, but you did well, Chris, so thank you for rolling out today.
good, good. And, as you were saying, Thomas, Centaur's in space, but not yet in orbit, right?
Absolutely. So this is his first burn. Again, 6.5 minutes into flight right now, and this is the first burn of what they call the main engine. And this is a little bit of nomenclature that differs from some other rockets. In the Atlas line of rockets, ULA actually refers to the RL-10 on the upper stage as the main engine, and the RD-180 powered first stage as the booster. So this is what we call the first main engine burn. So the next milestone we're coming up on is actually MECO 1, our main engine cutoff 1. And that's coming up about 12 minutes into flight. So a little over 5 minutes left prior to this burn completing. And again, this will reach the initial low Earth orbit parking orbit. And again, I love these live telemetry views. If you look at the top right of your screen, that's live telemetry coming from the rocket. You can see it updating every second or so. The apogee is the highest point in the orbit. Basically, imagine the engine shut down right now. That would be the orbit it's in. And you can tell it's not actually in orbit yet because the perigee is very negative. But you see that number getting closer and closer to 0. Towards the end of this burn, you will see both of those numbers be roughly the same, actually. It'll be a roughly circular parking orbit. I don't think we actually know the exact numbers, but you'll see those get closer to a circular orbit, and that's where the Centaur stage and the GOES-T satellite will coast towards the equator prior to the second burn. And you can also see that inclination we were talking about. Again, 28.5 degrees or so is the inclination you can reach from Cape Canaveral. And you'll see that inclination change for the third burn. Although that third burn happens over 3 hours into the flight, we'll be staying tuned to live coverage from NASA and ULA on that particular burn. But we'll stay tuned for that second burn because that only happens about 20 minutes or so after the launch.
And what's always interesting about the Atlas to me, Thomas, is exactly sort of what we are seeing here, right? Where that very, very slow but methodical increase of the of the perigee due to that low thrust but extremely high efficiency in terms of ISP of that RL-10 engine on the upper stage. And I think this is one of the really good examples where you can very calmly see how the orbits change as you climb to orbit.
Gotcha.
And you
Yeah,
can
this-
see as we're
Yep,
talking
go
about
ahead.
that perigee number now at the 1,900. Okay, Thomas, you're going to have to take it over. I've got to leave.
Yep, you got it, Chris.
Being told that we have to leave even though the launch isn't over. So got to take over, Tom.
You got it. Chris, thank you for rolling out to the field today, and thank you for that tracking camera. Again, we're now looking at live telemetry from ULA. That was Chris Gebhardt from NASASpaceflight, the assistant managing editor, rolling out there in the field for today. And we are now looking at that live telemetry again. This first burn will get GOES-T and the Centaur upper stage into a parking orbit. And it sounds like since we're being told to pack up in the field, we'll continue our coverage until the end of this burn. There will be further coverage on social media channels from NASA and ULA on the final two burns prior to spacecraft separation. So that's where we'll be staying tuned there. But this burn, not yet quite finished. The satellite not yet in orbit, but we're getting really close. Just about 2 minutes left in this burn. While we have been live covering this ascent here, we did get another question here from Ben that we can take quick. Does this rocket not always have boosters? That ties right into what we're watching now. It all depends on the satellite and what orbit they're being deployed into. So this particular satellite is being deployed into a transfer orbit that allows its onboard propellant to do the rest of the maneuvering towards its operational geostationary orbit, but also gives it enough time to perform some checkouts. We talked about this a little bit earlier in the process, in the live coverage, but GOES-T will actually be conducting checkouts all the way until January of 2023. There's a lot of instrument and spacecraft system checkouts that occur prior to actually entering operations. And so balancing all of those factors and designing the mission the best way for the satellite to complete its objectives determines what kind of orbit you want to deploy into. And then once you have both the mass of the satellite and the orbit it's going into initially, that's how you determine the rocket configuration. And if you're launching on an Atlas V with ULA, that determines how many boosters you need. And this particular flight profile needed not quite the most powerful Atlas V configuration. This is a 4-booster configuration instead of 5, but you can also see Atlas Vs with as few as 0 boosters, as your question mentions. So all depends on the mission. Also, some quick Super Chat support here. Wayne with some support and Billy with some Super Chat support just to say hi. So thank you to you both for your support. We appreciate that. And thank you to everyone who just tunes into this coverage. We really do appreciate it. Lets us do what we do. We are coming up on that T plus 12-minute mark, or the L plus 12-minute mark, where we are expecting the end of this first upper stage burn. So let's take a look as GOES-T reaches its initial orbit. You see that positive perigee now. And there you have it, upper stage shutdown. The main engine cutoff 1 milestone for today's launch has been reached. You can see a 170 by 489-ish kilometer parking orbit. So that's a low Earth orbit parking orbit. That is not the orbit GOES-T will be deployed into, but it's the first step on the way there. There will be 2 additional burns of the Centaur upper stage prior to separating the spacecraft, and that coverage will continue via the social media channels of NASA and ULA. But so far, the early phase of ascent has gone well. Atlas V done a great job so far, and GOES-T well on its way to separating and beginning its checkouts and operations. So thank you all so much for tuning in. I want to go quick around the horn to the NASA Spaceflight team. We had Chris Gebhardt out there in the field for NASA Spaceflight offering some coverage. Also, quick shout out to FleetCam here, providing an additional view of the launch as well. Also joining us on commentary was Hagen Warren, science writer for NASA Spaceflight. Hagen, thank you so much for joining commentary today.
Of course, had so much fun watching, and gosh, it's so cool to know that we have another awesome weather satellite on its way to start its mission.
Absolutely. Also out there in the field today was Julia Bergeron with the photography skills for today's launch. Julia, thank you so much for your support and looking forward to your imagery today.
Why, thank you. I'm working on my editing now. It's been a pleasure to join you all today. And I just want to say one more extra thank you to our members. You make what we've been doing recently and our channels grow. So I want to thank you for that. Everybody who just tunes in on social media, on our YouTube channel, L2, all of that. I just really appreciate y'all.
Of course, can't be said enough. We also got Michael Baylor in the background doing the production for today's live coverage, so thank you so much to Michael for all of your hard work. Greatly appreciated as always. Also, a quick shout out to Stephen Marr, who's out there for photography purposes as well. So looking forward to some of the launch photos Stephen brings to the table for today's launch. I know he was watching from a very cool perspective, so stay tuned on that. And then here, my name is Thomas Burkhart, News Director for NASA Spaceflight, offering some commentary as well. Thank you all so much for watching. Stay tuned to NASA Spaceflight for future space news coverage, both here on the YouTube channel and at NASASpaceflight.com. Until our next live coverage, this is the NASA Spaceflight team signing off. See you next time.
We have liftoff. Propulsion continues to be normal.
The chamber pressure looks good.
Doubling up. Roger, roll, Atlantic.
Water towers can fly! Yes!
Echo Delta nominal.
Flight down, lead off. Bring in, SC off.
Yikes. You bet. Concur. We don't need any more of these.